Okay, so if you're watching this video, hopefully you have access to homework one. So homework one I have open over here. And the idea of this lesson and the accompanying homework is to just get you familiar with Python. Kind of lets you see some basic flow, how people just code in general, and then have you play with specific aspects of Python. So the first and most important thing we're going to talk about in this lesson is going to be just straight up making variables. And you'll notice I have the homework open here. And as I go along in the lesson, I'll reference how and where that will be used in the homework. So just for a second, variables are essentially where we're going to store information in Python. So if I type in any set of letters, so like A, S, D, F, once I have this first letter here, I can follow it up by any letter, underscores, or any number, any combination of this. And then if I say equals and use this little equal sign, I can assign some value to this variable. Now this is a little ridiculous. We can start a little bit more simply. We can say our variable 1 is equal to my name Kai. And maybe variable 2 is equal to the number 13. Or any variable names we want. Let's say we want to define a variable pi. That could be 3.14. And we could keep going. We could do a bunch of physical constants like this. We could have a variable epsilon. That could be equal to something, in this case 7.61, etc., etc., etc. So here what I'm doing is I'm just setting variables, or I'm setting some value to some variable name. Okay, so here in the homework, what I'm asking you to do is make a variable. And with this homework, I'll probably be adding things like pi. So you'll be adding, you'll say add, or put the value of pi here. And I'll have you maybe do 5 or 6 physical constants. And if you're doing something that's like maybe the speed of light, so we'll call that c light, this might be, 300 million. So that's 1, 2, that's 300 million. If you're doing a physical constant like this, we'll do meters per second in the comment on the side so we can keep track of units when units are important. So in our homework, we'll be adding things like this. We'll be making variables, and then you'll be returning the variables you've made. And then I will look at that list of your variables and make sure you made them correctly. Okay, so this is the very simple act of making variables. Now, when we make a variable, you'll notice when I typed in, let me make these a little bit bigger. When I typed in like words, I use quotation marks. So I could make, so here I am typing words. So I can make this 2 ways. I can use the single or the double quotation mark like this. Both of these work, and they're both convenient. So if I wanted to do like a quote, I can use the single, then say this is a quote. So these is what's called, these are what are called strings. So if I look at variable 1 in Spider, if I'm on a specific line, I can hit F9 to run just that line. So it ran just variable 1 right here. And if I look at this in my variable explorer, variable 1 is type string of size 1. It says here I am typing words. Now this same variable, I can call this variable 2 now. Let's call it 2. The same variable, when I use the double quotation marks, I run that. You can see it's exactly the same. Now if I'm trying to do a quote, in a single quotation mark, I can put these double quotation marks, and they'll be included as a part of the string. So right now I'm making variables that are string typed, or like I'm setting an object in my memory that's a string type object. Okay, so I can also do like words here. So this is my variable name. My variable is named words here. And I can use double quotes and say, don't do that again. And now using the double quotes, you can see the single quote ends up inside of the string. And then if there's a combination of quotes, you get kind of fancy, and we can play with that in a little while if necessary. But you probably won't be encountering that too often. Okay, so those were string variables, and I can even keep those up for a second. These were string variables we wrote here. Now, what about these numbers? So there's three types of number variables we'll deal with. So the first type of variable is a integer type. So if I look at variable, so we have 1, 2, this will now be variable 3. If I look at this, I'll either highlight it or run the line. Variable 3, its type is an integer, and its value is 13. So I have a named variable called variable 3 of integer type with value 13. Now if I go to pi here, when you're on this is what's called a float type. So we have integers and we have floats, and the difference is floats sort of assume this like imprecision, whereas an integer is 13. Now if I write something like this, if I say the value is equal to 13.0000000, this sort of implies like a precision here, whereas this 13 is just a 13 exactly. So now if I look at value, we see value is a float even though it's 13.0, and it's a float of 13.0 as opposed to an integer of 13. And the last thing we have is a complex variable, or a complex number. And I believe we can write that like 1 plus 3i. Let's see. Well, very quickly, let me show you one of the most important skills you're going to need to learn when coding. It's the Google search. How to maybe do how to make complex number Python. So complex numbers in Python, I generally prefer to click on the first Stack Overflow link. And here we go. Okay, you can put a J or J after a number to make it imaginary. So I didn't put an I, but I should have put J. So my complex number is 1 plus 3j, and if we come over here, our variable name complex number is type complex with size of 1, and the value is 1.3j. So now we have our numbers. Let's go ahead and add a comment here. We have our numbers. We have different types of strings. So these are different variable types or object types. And then some of the other things we're going to deal with are lists. So what a list looks like, here's an example list, is lists always appear inside of these square brackets. And a list is what we call like an iterable, or something you can iterate over. So a list might hold a shopping list, right? So I want bananas. So that'd be the first item in my list. The next might be apples. We're going to be healthy. We'll grab some eggs, bacon, because we're not that healthy, etc. Right? So my list can have all of these extra things in it. Let me just go ahead and make this a little bit bigger so you can. So my list can have all of these different things in it. And if I look at this list, I can run it. So I just hit F9 on this line. I can run it. And our example list here, our variable explorer now says, our example list, that's the name of the variable, is a list type of size 5. So now, as opposed to all of these other variables we've made, this one now has a size larger than 1. And it's a list that has the first item, or the index 0 item of bananas, the index 0 item, or index 1 item apples, index 2 item eggs, index 3 bacon, and index 4 the etc. Okay, so this is our list. And there's also things like tuples. So the difference between a list and a tuple is what's called mutability. And we'll talk about that in just a second. But my tuple can be built exactly the same. We can run this here. So I'm highlighting this line. I'll hit F9. Our example tuple can be exactly the same, but it's type tuple, same size, and it has the same things inside of it. But you'll notice the parentheses as opposed to the brackets. And what it means to be mutable is, let's say on my shopping list, I want to add an item. So while I'm out, I don't just want what's in this list to start with, but I also need to pick up sandpaper, for example. So our new list can be equal to the example list that we used to have, and I could add a list to it. So maybe the only item in my list is sandpaper. We can run this line and see our new list is now of length 6, and it includes sandpaper as the last item in the list. But if I try to do the same thing to a tuple, it's not going to work. So we'll call this our new tuple. And we're going to say, okay, so you had a tuple, you want to add a new tuple, you want to add sandpaper to this. You can only concatenate tuple. Let's see. Let's make this. Tuples are a little funny to deal with. So when we make this new tuple, it also adds that there. Because I didn't make the change in place. Okay, this is a finer point to programming that we usually don't need to worry about. But when you can make changes to an object, or you can make a new object. So in this example, I have my example list, and then I'm making a new list, which is a completely separate entity from the example list. And I have my example tuple, and I'm making a new tuple that's a completely separate entity from the example tuple. Now, if I want to change my list in place, what I could do is I could append sandpaper to the end of the list. So if we go to example list, right now it's length 5. Here's our example list. If I append sandpaper to the end, it now becomes length 6. But you see it changed this variable in place, which is a little detail I forgot. So the list, once it's made, can still be changed. If we do this to the tuple, this is where we get the issue. We can't append something to a tuple because it's immutable. Okay, that was probably way too much detail and a little bit of a failure on my part, but we'll move on. So the other types you're going to deal with, there's integers, floats, complex strings, tuples, and lists. There's also the dictionary type called the dict. There is the bool type, which stands for boolean, or like boolean. And the last one we didn't cover, list, bool, are just these two. So dictionaries, if we're going with the whole shopping list idea, an example of a dictionary is, let's say we want to know how many of each thing we want in our shopping list. So we don't just want bananas, but we want bananas. Wow, how do you spell bananas? And we want 15 of them. And you want apples, and we want 12 of them. So what I'm doing here is I'm assigning a key and a value. And let's go with the last one. Let's do eggs. And we can assign a dozen. So you notice a dozen. Wow. A dozen? Well, now I need to know how that's spelled because that seems dozen. Okay, perfect. So we'll assign a dozen. So eggs, our key eggs will be assigned the value dozen. So you'll notice that the value doesn't have to be an integer. It could be a float. Maybe you want 12 and a half apples. It could be a string, or it could even be a list. Maybe our bacon, so the keyword bacon, will return a list of different types of bacon. Maybe I want pork bacon, and I want turkey bacon, and I want tofu, bacon. Okay, so now I've made a new example dictionary object, and if we run this, oh, I hit F8, which accidentally brings up static code analysis. I'm just going to close that really fast. So if we run this, we can look at our example dictionary right here. If you double click, it'll bring this up. And we can see apples, the key, was assigned 12.5. We can see bacon, the key, was assigned this list of size 3, pork, turkey, tofu. We see bananas was assigned an integer value of 15, and the key eggs was assigned a string, a dozen. Now, if we want to access those from this variable, we use the square brackets and we type in the key we want. Now, you'll notice that when it created this example dictionary, it's not in the same order we put things in. And that's because a dictionary is unordered. Whereas something like the example list, it has a structured order where bananas is always in index 0, apples is always in index 1. So this unordered list is a little bit different. But this unordered dictionary. But the good news is, if we ever want to grab a value, well, we can say how many bananas, how many. Well, we ask in our dictionary, what's the value associated with the key bananas? And we can see how many is then returned with that value of 15. So if we change this to apples, how many is returned with the value of 12.5. And if we change this key, so we're asking, give with the dictionary, what's the value of this key? This will return how pork, turkey, and tofu. And then finally, booleans. These are easy. You have boolean values true, and you have boolean values false. And this will be used with logic statements we'll look at later on. A quick example would be if apples is less than 5, so you don't have a value for apples, so we can use our dictionary here. If the value in our dictionary associated with the key apples is less than 6, then actually let's say if it's greater than 6, because we don't need 12.5 apples, we can say if this is greater than 6, we can redefine it to be equal to, so we're going to redefine the value of this key to be equal to 6. Oops, 6. So we could do something like this, and if I run this, you'll notice if we go up to our example dictionary, apples now gets a value of 6 when it used to be 12.5. But what was this really looking at? We're asking for logic right here. And if I run that logic, it's going to say false because 6 is greater than 6. So we could also say maybe just if true, do something. And so these are what are called Boolean variables. And we'll use that for most of our logic. So in here is hidden the Boolean variable false. Okay. So those are our different types. In the homework, it should be pretty straightforward and pretty easy. But what I've done is I've saved a bunch of variables. So variables 0 through 10. In Python, we always index at 0, so I try to use 0 to start things off. In variables 0 through 10, we have our first variable, which is a tuple, signified by these parentheses, with a string inside of it, a string inside of it, an integer, a string, and a string. So that's variable 0. So your job is to say variable 0 is a tuple. And so here's an example of the string values I want you to put in. And what you're building is you're going to be building a dictionary where the key represents what variable number it was, and the value of that key represents the type of that variable. So in our case, variable 0 is a tuple. Variable 1 is a plain string. It's just a string. Variable 2 is also a string. Variable 3 is a float. And so you can go through here, and you'll notice I threw some tricky things in like this. If you don't know what this function does, an easy thing you can do is if you highlight it, or if you're on the line of that function, hit F9, we can see, okay, I have variable 4 saved. If I go to my variable explorer, variable 4 has the type string. Even though it looks as if it could be a float, this little function here has converted it into a string. So go through the rest of the variables, and what I want you to do is fill out this dictionary. At the end, it should be something a little bit more like this. And then maybe number 4, whatever that one would be. Okay, so that should get you through Q0, where you're just setting values to variables, and Q1, where you're identifying the data types of different variables. And those main data types are integers, floats, complex numbers, strings, dictionaries, tuples, lists, booleans, etc. And be aware the homework might not look exactly like this when it's released with this video. Okay, so that gets us to Q1. I'm going to add in with a little break here. So this allows me to kind of cut my code up into smaller sections and make what are called like cells in my code. So after Q1, there's a quick little exercise where I'm going to have you do one of those Google searches I did to try to figure out how to programmatically determine the variable type. Now I've included the answer, try not to look. Try to find it. Try to find this from your actual Google search. It should be on this website, which I think is the first Stack Overflow link from this search. Oh, what was the search? Oh, how to check variable type Python. Okay, so now Q2, Q3, and Q4, they're going to go into in-depth, I say in-depth, not too deep, in-depth operations you can do with lists. So when you have a list, you'll notice earlier I did what was like an appending, and I did I did append, and I also did something like example list or new list equals, oh geez, hold on. I did something like new list equals example list plus sandpaper. I did this earlier. So what I'm doing is a list object, a tuple object, a dictionary object, they have built-in functions or like built-in functionality. So we don't have to do everything from scratch. People have decided, you know, if I'm working with a list, there's some important things that like a list should be able to do. So some of those things for a list, so important things a list can do, this is just some of them, is you should be able to add lists together. That's one of those. I'm just going to keep this uncommented for a second. Oh, you'll notice that I'm doing the pound space and then saying then normal text. These are what are called comments. This won't run in the code. Only the uncommented things will run. Now, if I try to run this code, it's not actual code, so it'll break my computer. So if we watch over here in the bottom right, I get a syntax error because what I've typed here doesn't really mean anything. Now, if I do this, these are just comments, and it doesn't execute anything at all. But I'm just going to make it easy to read for now. So important things a list can do. It can add lists together. You can append values to the end of a list. And you'll notice list is like in purple. That's because it's a Python, it's a special Python keyword, and we'll talk about those in a sec. So you can add lists together. You can append values to the end of a list. You can slice lists, and you can search in lists. So these are some of the main things you can do. So what's an example of each of those? So I'm going to comment this out so I can run this code block, denoted by the pound space %%. So let's say I have list 1, and that is this list up here, all the way up to bacon. And then let's say I have list 2. So this is my healthy list, and this is my unhealthy list. I think ice cream's right in the middle of those two. Say sour watermelon candy. I don't know. how to spell watermelon when you're on the spotlight like this. The next thing will be candy corn. We'll call that good for that list. So let's say list 1, this is my healthy list. So I'm adding a comment so I know what this list means. Let's say list 2, this is my sweets list. And you could even have a list 3. So I'm going to copy and paste. So I have list 1, list 2, list 3. And let's say list 3 is my drinks list. So I have bananas, apples, eggs, bacon. I have ice cream, sour watermelon candy, and candy corn. And over here, I want Dr. Pepper. Maybe I want water. And another thing I need to buy is ginger ale. So these 3 lists are fine, but they were built independent of each other. So I can simply do a shopping list. I'm going to make a variable that's the addition of these 3, as simple as this. 1 plus 2 plus list 3. So now if we look at list 1, 2, and 3 in our variable explorer, we get bananas, we get our ice cream, we get our Dr. Pepper and ginger ale. And then if we want to look, when you run our shopping list, it adds it here. This is now size 10, so 4 plus 3 plus 3 is 10. And it has all of those items put onto the same list. Now we made this shopping list, but oh wait, we forgot we need to add something else. Well, we were adding lists together and they were added into the same list. Well, I can append a string into that list. Maybe I want to add onto my shopping list, what do you buy at the store? Tortillas. Now my shopping list is going to grow by 1 and tortillas is going to be added to the end of it there. Well, let's do some list slicing. So I was adding lists together and this was appending values to the end of a list. You'll notice if I append tortillas in its own list, so this is a list of length 1. If I append tortillas in its own list, this grows by 1 again, but now instead of a string, it's appending the list itself. Okay, well, let's say that was a mistake. I didn't want to append this list here. I can slice it off. So I can do shopping list equals my shopping list, where I grab everything until the last one. So there's 2 ways I can do this. I can count from the right to the left. So if we open up this list again, I can count from the right to the left or from the bottom to the top. Those are equivalent. If we look at the list, oh shoot, let's do this. If you look at the list here, we can count from the right to left, which is equivalent from bottom to top. Or we can count from top to bottom. So if I want everything, I always use this, this colon, but I can grab everything from 0 to 10, like this, and we can look at what that looks like. So that grabs up to ginger ale. You'll notice it doesn't include 10, because it's gonna grab the first 10 objects here. So from 0 up until 10, but not including 10, we can get up to ginger ale. So if we want to go to the very end and grab everything but the messed up tortillas, we can go up to 11, and that'll grab all of that. Or the opposite is we can count backwards. So if I know tortillas is the very end, that's up until the negative first. Oh, whoops. Let's grab this. So that grabs everything up until negative 1. Now if I want to also take off ginger ale, so this is the negative first one, this is my negative second index. So up to everything up until the negative 2. So now ginger ale is also removed from that list. So that's slicing lists. And then the last thing I can do, and this is sort of a little bit more advanced, but it'll be pretty useful, is I can ask if salsa is in my shopping list. And if it is, I will print salsa is in the list. So it's another thing that's really important and really quite convenient you can do with lists. You can search inside of them, but this uses sort of like conditional statements and stuff. So if I just highlight this inner part, this will return a Boolean. So false, salsa isn't in the list. If I highlight this whole thing and run it, it's going to say if salsa in shopping list, print. Now salsa is not in the shopping list, so it didn't print anything. Now we can go ahead and add salsa to the shopping list. So we can use append, get rid of these brackets, and we'll add salsa. So we're adding a string to the list called salsa. Now if we run this again, it's going to print salsa is in the list. So those are the sort of like some of the built-in functions that are pretty important associated with lists. And you'll see in your homework, it's very simple. It just asks you to get a list, append the second item to the list, append the third item to the list, and return it as the final appended list. So you'll put in code here that does that. And then the next thing you're going to do is you have a few lists and you're going to add them all together. And then from some list, you're going to slice things off. And then finally, you're going to return. And then finally, I'll put all of those into their own list. I've already done this, and I'm going to check all of your answers. So one thing you might notice is all of the code you're going to be working on is built inside of functions. So this, when it says def and then has a bolded name, is a function. In our case, I've defined the function q0 underscore setting underscore variables. And then we can run that function here. And so in your homework, what's going to happen is when I run a function, it returns values that are important to me for grading. And so this is how I can automate all of the, automate how I check all of the values up front. And then for specific problems where it's very easy to kind of game the system, I'll check them by hand. Okay, so here we have our list questions where you just simply add a list, or you append a list, you add some lists together, you slice up a list. I'm not going to make you search in a list, even though it's pretty trivial. Then over here, we'll do strings next. So some things we can do with strings, we can add. We can add strings together. So let's say I have a first name. In this case, let's say that's John, and there's a second name, and that's John Doe. Let's just say I want the name. Well, I can add these strings together. I can add the first name plus, let's say I want a space in there, and then I can add the first name plus a space plus the second name. And so if I run this, I can run the first name, and you see it's going to get the value John over here. I can run the second name, it's going to get the value Doe over here. And then when I run name, it's equal to John plus space plus Doe. We get John Doe. Simple, simple. Okay. So that's the first easy part there. Adding strings is easy peasy, easy peasy. The next thing that's important to know with strings is how to split them. So it's easy to go, well, what if the name is given to me, but my record keeping, I need to have the first name and the last name. So I can do name split equals name dot split. So I'm just making a variable name here, and that variable is going to hold the result of this function, the functionality that the name variable has. So the name variable is a string. So let's go up here. Name variable is a string, John Doe. And strings have this built-in functionality that they can be split, just like lists have the built-in functionality that you can append things to them. So we can split this at the space, and what it's going to return, so we'll look at name split here, is a list. So everywhere there's a space in that string, it's going to return an item in the list. So let's go a little bit, let's just make this a sentence, is the man who was passed on the freeway. John Doe is a man who's passed on the freeway. Good enough. I don't know how to spell. Forgive me. Let's see, past. Which one is it? P-A-S-S-E. Passed. There we go. John Doe is the man who has passed on the freeway. If I run this, so I'm redefining my name to be that giant sentence. And then I'm going to split it at the space. So there's a bunch of spaces here. So name split is now a list of size 11. So you can split things like that. Another thing that splitting is really quite useful is, let's say I have a named file.csv. Well, I could split on the period here, and it's going to return, oh, whoops, I need to run this. So name is now named file.csv. That's going to return a list of these two. Now, one thing I forgot to mention in a list that's actually like quite critical is you can access any item inside of a list. And to do that, let's say access any item in list. What you do is you put in that item's index. So bananas is at index 0. So if I say list 0, it's going to return bananas. Now, we looked at slicing. So if I did like list 0 through 2, so it's going to have 0, 1. It's going to go up to 2, but it's not going to include 2. So 0, 1, excluding 2. It's going to be that sliced list, apples and bananas. And I can even slice with just 1. And just get a list of bananas as opposed to the string bananas. But if I want to access an item inside of a list, I can just say the item's at this index, grab it for me. So when I do name equals name.file, and then I split it at the period, name split has two items in the list, the named file and the dot and the CSV part after the dot. So if I wanted the name of this file, I can then do name of file equals, well, I know my name split is a list, and the location 0 has the name. So my name of file can then just grab that single value. Okay, so that's some operations for lists. You can also slice lists. So let's say I want to remove that CSV in another way. What I can do is I can do name slice equals, well, just like not a dictionary, like a list, you can count 0, 1, 2, 3, and slice from 0 to 3. With a string, you can count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So you can count each letter or number or character in the string as if it was indexed at its location in the string. So I can slice my name, and I can slice it starting at 0, or kind of implicitly the 0 is put there when I say everything, up until either, let's see, this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So up until 10, because it's just going to grab the first 9 here. Or it's going to grab the first 10, but that's going to end at index 9. That's always been confusing. My name slice is going to return that same file, or I could go backwards, -1, -2, -3, -4. So -4. And new slice shouldn't change, so we'll run that, and it's still that named file there. So that returns the same values. So you can also slice there with strings. Okay? And then finally, we have numbers to work with. Numbers are pretty easy. We have like the basic operations. So we have val1 equals 1.5, val2 equals, I'm just kind of making these up, and val3 equals 6. Okay, we can add these, and that'll just be val1 plus val2 plus val3. Oh, so that these aren't defined. So I have to run these, and then I run this last line. Okay, so my added values is just going to be the addition of 1.5 plus 2.5, which is 4, plus 6, which is 10. So added values over here is 10. And you'll notice it's a 10.0. That's because it added a float, and an integer. And so the result of adding floats and integers together is a float. Now we can also do, let's say this is 2 and 1, we can also do this. And now we'll get an integer result of adding integers by themselves. Okay? So that's the first thing you can do. It's pretty easy. Now the next thing you can do is, instead of added values, well, we have subtract. So, and that's exactly how you'd imagine it. So you can run that. We have divide. Now you'll have to be careful because divided by zeros can be an issue. So value 1 divided by value 2. So 1.5 divided by 2, which is going to be 0.75, or 0.05, sorry. So we have divided values right there. Wait a minute. It is 0.75. It had the 1 saved on it from earlier when it was defined as an integer. So we can have divided values here. Now if we divide by 0, you can watch what happens. We get an error. 0 division error, float division by 0. So that's a problem. You just have to avoid that and be smart. So we have divided by, so val 2. We have multiplication. And this uses the star, which is shift 8. So value 1 times value 2. So value 1 is 1.5, value 2 is 2. So we run this. We get multiplied values, and that adds up to 3, or that equals 3, just how we expect. And then finally, we can do powers. So we could do value 1 raised to value 2. So in this case, instead of using a caret, you use a double star. So 1.5 squared is going to give us that powered value. So let's see, P, LMNOP. So 1.5 squared is 2.25, apparently. And we can even, if you remember, like you do like a cubed root. So instead of raising to the 2, we could do cubed root equals, let's say, val 2. So we're going to get the cubed root of 2. So if I raise to the 1 over 3, that's equivalent to taking the cubed root of 3. So now my cubed value up here is 0.126. Great. And then, of course, when you're doing math, order of operations matters. So I can do order of operations. So I could do val 1 plus val 2 in parentheses and then divided by val 3, which is going to be very different than if I do val 1 plus val 2 divided by val 3. Because in this case, it's equivalent to adding these parentheses in, because the division always happens first. So you follow your normal math conventions here. And so like if I added a power here, this is first raised to the third, and then this is divided by that, and then they're added. And so it'll follow all of your same math conventions in terms of like parentheses, exponents, etc., 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 addition, subtraction. Okay. So that'll get you through the numbers part of the homework. It should be pretty fast and easy. And again, this homework isn't intended to like push you too hard. What you're really trying to do is just get very familiar working in Python. Because when we do actual math problems, it's really just a composition of all of these very easy operations, but you can't make mistakes in code or the code tries to run your mistakes. So you just have to be very familiar with inputting things correctly and understanding how they operate before they run. And so finally, the last thing is I'm going to have you search for all of the reserved Python keywords that exist for Python 3, and then return 10 of them. And so an example of that might be Python 3 list keywords. So if we go here, Python keywords. Here are a bunch of keywords that are reserved. So if I try to type in return, you'll notice it goes all blue. If I try to type in pass, you'll notice it goes all blue. If I type in true, you notice it goes red. If I type in, or purple. If I type in str, you'll notice it goes purple. I cannot use these as variables. Or rather, if I do use them as variables, I risk breaking the entire, that entire code. So if I do like return equals 13, it's saying, well, return is already reserved, so let's not do that one. And so what we want to do is just sort of like avoid trying to use these in that way. And so these are just the keywords that have been reserved, and each of them has a purpose. So and, it helps us with logic. As, it allows us to like reassign a variable name to something else. Assert makes sure that a variable has a certain value. Break breaks us out of a loop. And we'll go over a lot of these as we work through the rest of the lessons. So you've seen I use define here. You'll see I use return here. I use print here. I believe print is one of these. I use, what else do I use? I use length here. I use class all the way up here. And make sure when you do your homework, you actually put your first name in there. You put your last name in there. And if you have a UID, put it in here, and then your email, so that I have a way of contacting you when I graded the homeworks. I use class here, and I use define here, and I use self here. There's a lot of like these reserved keywords that Python wants to use, like doesn't want you to reassign, or else it could break things. So we'll end the video here. Hopefully that's enough to get you through the homework. Send questions as they come up, and hopefully we can talk about your experience with the homework later.